You can't really find anyone nowadays who doesn't use Wi-Fi at home in one way or another. Have you ever wondered why your Wi-Fi might be faster or slower than your friends when you're at their house? Well, in this video, we're diving into the different Wi-Fi standards and breaking down exactly why your Wi-Fi might suck. Stay tuned. To understand why, let's start with the very first Wi-Fi standard, ETA 2.11, which came out in 1997. By the way, IEEE 802 is the committee that creates these networking standards. They have many standards that start with 802, and Wi-Fi falls under the 802.11 family. Now, back to the first Wi-Fi standard. 802.11 came out in 1997. It had a speed of 2 megabit per second. And I know, just thinking about having that speed today gives you a headache. It used the 2.4 gigahertz frequency band, which means the signal could travel farther and pass through obstacles like walls. But here's the problem. Wi-Fi routers are not the only devices using 2.4 frequency band. Things like microwaves, Bluetooth devices, baby monitors, or even some smart light bulbs can use the same band, and that can interfere with your Wi-Fi signal. In 1999, 802.11a was released with a speed of 54 megabit per second, which is way faster than 2 megabit per second, right? But here's the twist. It used the 5 gigahertz frequency band instead of 2.4. So what's the difference? 5 gigahertz is faster and usually has less interference, which means your data can reach you better and faster. But it doesn't penetrate walls and obstacles like 2.4 did. That makes it annoying if you're far away from the router. And if your device didn't support 5 gigahertz band, you'd be like, man, really? What am I supposed to do now? Couldn't they just make a Wi-Fi version that works on 2.4 but it still gives faster speeds? Well, don't worry, they did. In 2003, we got 802.11g. This one works on the 2.4 gigahertz band and delivers 54 megabit per second, just like 802.11a. Woohoo! And here's another cool thing. It's backward compatible with 802.11b, since both operate on 2.4 gigahertz band. 802.11b actually came out the same year as 802.11a. It operated on the 2.4 gigahertz band, but its speed was only 11 megabit per second, which was not really enough. 6 years later, we got 802.11n, and this is when they started making the names easier by calling it Wi-Fi 4. If you want, you can think of the older ones as Wi-Fi 1, 2, and 3. So what's special about Wi-Fi 4? It supports both 2.4 and 5 gigahertz band on the same device, and it can reach speeds of up to 600 megabit per second. Older routers typically used one antenna to send data, which limited performance. Wi-Fi 4 introduced MIMO, multiple input, multiple output, meaning the router could use multiple antennas to send multiple data streams at once, making it faster. But one thing still didn't change. The router could only communicate with one device at a time. So if two devices needed data, the router would go back and forth. Device 1, device 2, device 1, device 2. Each device had to wait its turn. Hopefully, the next version fixed that problem. In 2013, we got 802.11ac, also known as Wi-Fi 5. As always, newer versions come faster and more efficient. Wi-Fi 5 reached speeds of over 3.5 gigabit per second, and again, it used only the 5 gigahertz band. It also introduced MU-MIMO, multi-user MIMO, which means the router could now communicate with multiple devices at the same time. No waiting in line. Huge upgrade, right? Wi-Fi 5 also supported wider channel bandwidth, up to 160 MHz, compared to 40 MHz in Wi-Fi 4. More channel bandwidth can transfer more data. Think of it like a highway. More lanes, more cars can travel. More channel bandwidth, more data can be transferred. Next came 802.11ax, also known as Wi-Fi 6, released in 2021. It increased the theoretical speed to 9.6 gigabit per second, and it worked on both 2.4 and 5 gigahertz bands. Wi-Fi 6 still uses MU-MIMO, but it also introduced a major feature called OFDMA. OFDMA stands for Orthogonal Frequency Division Multiple Access. Do you remember when we talked about GSM and CDMA in cellular networks? OFDMA is similar in concept to how CDMA improved efficiency. In CDMA, users shared the same channel, but each one used a unique code to separate their signal from everyone else, allowing for more efficient communication. The same idea applies to Wi-Fi 6. If you're in a crowded place like a stadium or an airport, many people can use the Wi-Fi at the same time with little to no impact on speed, something that wasn't as reliable with older Wi-Fi versions. The latest version, for now, is Wi-Fi 7, also known as 802.11be, released in 2024. It increased the speed to about 46 gigabit per second and introduced MLO, multi-link operation, meaning it can use 2.4, 5, and 6 gigahertz of frequency bands simultaneously if your device supports it. It means that your device, either phone or laptop or computer, can use 2.4, 5, and 6 gigahertz of frequency bands at the same time. It also expands channel bandwidth from 160 MHz to 320 MHz, which is extremely wide and allows massive amounts of data to move quickly. Wi-Fi 7 is also designed to use power more efficiently through smarter resource allocation, along with other performance upgrades. Now you know what these Wi-Fi standards are, and next time you're buying a router, you'll know exactly which one to choose. Thanks for watching, and I'll see you in the next one.